Hello everyone, you're welcome to this lesson. In this video, you are going to learn about the axioms of probability. Okay, so let's look at what a probability is. So a probability is a number that is assigned to each member of a collection of events from a random experiment that satisfies the following. Okay, so when we are talking about a probability, it is any number that is assigned to a member of a collection of events, okay, from a random experiment that satisfy the following properties. So we have the first property to be the probability of S should be equal to 1, where S is the sample space. Okay, so what this means is that if you are performing an experiment, okay, and then you know that the experiment that you are performing, you are going to get some results or outcomes. Okay, we define a sample space which we are going to use for our analysis, and then this sample space is represented with the letter S. Okay, so what the first property is saying is that the probability of all the outcomes in the sample space, okay, the probability of the sum of all the outcomes in the sample space should be equal to 1. Okay, should be equal to 1. So if you have a sample space, okay, and then you have outcomes, let's say you have outcome A, B, C, and then D. What the first axiom is saying is that when you sum up the probability of all the outcomes in this sample space, it should be equal to 1. Okay, so in this case, let me clean this. That means that the probability of S should be equal to 1. So when you sum up all the probabilities of the outcomes in this sample space, we should get a value of 1. That's what the first axiom says. And then the second axiom says that the probability of E, okay, should be greater than or equal to 0, or should be less than or equal to 1 for any event what E. So let's say you have an event E, okay, which is a subset of the sample space. So what the second axiom is saying is that the probability of the event E, okay, should be greater than or equal to 0, or should be what, less than or equal to 1. Okay, so that's what it means. So let's say from this sample space that we have here, okay, we can have an event E, okay, which will contain the outcomes A and then B. Okay, so the probability of this event here, okay, should be within this range. Okay, should be within this range. It should be either greater than or equal to 0, or should be less than or equal to 1. Okay, so the probability of this event will actually be equal to 1 if all the outcomes, okay, in the event are the same as the outcomes in the sample space. That's when you are going to get 1. But if we have any other outcome, okay, which doesn't contain all the elements in the sample space, then the probability of the event A should be within this range. Okay, so it should be within 0 and 1. Okay, so that's what this means. Okay, so in this case, assuming that we have the probability of A, okay, outcome A to be equal to 0.1, outcome B to be 0.3, outcome C to be 0.5, and then outcome D to what, 0.1. Okay, so those are the probabilities of all the outcomes in this sample space. Okay, and then we have event E. Okay, so event E contains the outcome A and B. That means that the probability of event E, okay, will be equal to the probability of outcome 1 plus outcome A plus what, outcome B. That gives us a value for 0.4. So you see that the probability of this outcome here is between what, 1 is between what, 0 and 1, and that is what, 0.4. And then if you are to find the probability of the sample space, okay, that will be the sum of all the probabilities of the outcomes. So in that case, you are going to have 0.1 plus 0.3 plus 0.5 plus 0.1. So all this will give us a value of what, 1. So this is what the first axiom is saying. So I define the sample space and then give all the outcomes probabilities. And then the first axiom is saying that when you sum up the outcomes of all the when you sum up the outcomes, okay, in the sample space, we should get a value of 1. And then for any event in the sample space, its probability should be greater than or equal to 0 or should be less than or equal to 1. And then we chose an event E which has the outcomes A and B, and then we found its probability, and then that was for 0.4, and then that satisfies the second axiom also. So that's what the first and then the second axiom means. So let's look at the third axiom also. It says that for two events E1 and E2 with E1 intersection E2 equals 0, the probability of E1 union E2 is equal to the probability of E1 plus or the probability of what? E2. Okay, so assuming you have two events E1 and then E2, okay, and then the intersection of these two events is 0 or an empty set, then that means that the probability of their union, which is the probability of E1 union E2, okay, will be equal to the probability of E1, okay, plus the probability of what? E2. Okay, this is what it means. So let me explain this. If you have the intersection of two events to be a null set or an empty set, we call that a mutually exclusive event. Okay, call that mutually exclusive. So in this case, you are going to say that event E1 and then E2 are mutually exclusive because they don't have any outcome in common. So in that case, the probability of their union will be the probability of event 1 plus or the probability of what? Event 2. That's what it means. Okay, and then another thing that we can deduce from this is that since we know that the probability of since we know that two mutually exclusive events don't have any outcome in common, we find their probability, which will be the probability of E1 and then E2. Okay, the probability of E1 intersection E2, you are going to get 0, right? Because there are no common outcome between them. So you are not going to get probability values for that empty set because the set is empty. So how can you take a probability of an empty set? So for that reason, you are going to get 0 for the probability of E1 and then E2 if they are mutually exclusive. Okay, so about this union that we have here, in general, okay, if I have two events, okay, probably if I have two events A and then B, okay, then I have to find the probability of their union, which will be the probability of A union B. From the addition rule, that will be the probability of A plus the probability of B minus the probability of what? A intersection B. Okay, that's what is happening here. But in this case, what is happening is that E1 and then E2 are mutually exclusive events, which means that the probability of A intersection B is going to be 0. So that's why we just have the probability of E1 and the probability of what? E2 here. Okay. But this case is when we don't have mutually exclusive events. So this is what the assumptions of probability says. Okay, and then from these assumptions we can say that the probability of an event shouldn't be greater than the probability of a sample space, right? You know that, right? Because if I have a sample space, you know that the event was derived from the sample space, right? So we can say that the probability of the event which came up out of the sample space will be greater than the probability of what? Of the sample space. Okay, so let's consider two events, E1 and then E2. Okay, and then let's say E1 is contained in E2, then we can say that the probability of E1, okay, should either be less than or equal to the probability of what? E2. Okay, that's what it means. So there's no way that the probability of E1, which is contained in E2, will be greater than the probability of what? E2. So that's one thing we can deduce from the assumptions of probability. Thank you very much for watching this video. Please make sure you like the video and subscribe to the channel.